So in previous lessons for our TicTacToe game, we improved on the color and fonts used within the game, but it's still a little flat. This is forgivable for something as simple as a little TicTacToe game, but still we can add more in the visual effects area so that the gameplay is a little more engaging. So in this lesson, we'll add some simple animations when a game piece is picked up and placed down. In addition, we'll add a little more involved animation that's played when a player wins a round. Okay, let's tackle the game piece animation first. We will simply alter the size of the game piece as it's picked up and then put down. For this simple effect, we can sort of cheat and just manipulate the game piece's scale attribute in code. So in the game piece's code, you can make these alterations to the sprite's scale X and Y attributes, reducing to 80% of its original size when picked up, and then setting it back to 100% when dropped. This is done in the onGamePieceInput event function we have already created, which we mapped to the input event in order to support drag and drop. So we can see that code here. So now simply run the game, and when you pick up and put down a piece, its scale will change as predicted. One thing to note, the return to full size when placed on a tile is actually due to the sprite being replaced and attached to the tile. Your code above is used to return to full size in the situation where you drop not on a tile. Now for something a bit more ambitious. Currently when the player wins, there is no celebration in the game really. It just simply changes to the summary screen. You will now create an animation sequence that plays through prior to going to the summary screen. The plan is to have sort of a starburst animation play as soon as the winning piece is played on the board, and these particles will emanate from the center of the screen and radiate outwards towards the edges. Godot provides a node for this type of effect called Particle 2D. Go to the game tile scene and add a Particle 2D to the top of the scene tree. Rename it to Win Explosion. To render, this node utilizes the GPU. There's an alternate particle node that renders on the CPU called CPU Particle 2D. For this simple effect, which there's only really one instance, either type of node is appropriate. Performance isn't an issue here. So in this lesson, we'll use the GPU rendered Particle 2D node. Also, if you run into any issues with compatibility, you can convert a Particle 2D to a CPU Particle 2D just using the particle menu here. Particle nodes need a material applied in order to animate. So in the inspector under process material, click on that empty section and add a new particle material. You'll notice the default particles emitting from our sprite. It's not very exciting at this point, but particle material has many attributes to adjust in order to get the effect that you want. So first let's change the particle that is emitted from the default. We'll use a star particle image that a link will be in the description below for you to download this. I've placed it at Assets, Sprites, Star Particle. So under Texture, drag and drop this file onto the texture attribute. So now you'll see this particle image change, but they're still simply dribbling out the bottom. There's no initial velocity, and all that's in effect currently is gravity. So we want this to be more of an explosion with a steady trail of particles. So give the particles an initial velocity, and let's also add some randomness. So now they're shooting out of the right. As you can see, still they're affected by gravity. So this trajectory to the right is defined in the particle materials direction attribute. So let's change the spread to 180, and we'll now see the particles emit at 360 degrees or plus or minus 180 degrees. At this point, you can also choose to turn off gravity so that we have our particles emitting in random directions and keeping their initial trajectory. Currently, there is a steady stream of particles. We want more of an explosion effect again. That could be accomplished with what you might expect, the explosiveness property under time. Set that to 1 and then increase the number of particles that are emitted to something like 200 and set the lifetime to a little longer. We'll go 3 seconds. And let's also add some randomness to the lifetime. Let's try setting it to 0.5. So now let's make some adjustment to the color of the particles. Let's have them start as one color and then sort of fade into another over their lifetime. In the process material section, click on the particle material. And within that, click on color and then color ramp. And we'll create a new gradient texture. So click the gradient box and then the empty and create a new gradient. And click the pool color array. And let's go ahead and set color 0 to the blue we had from our color palette. And then let's leave color 1 as white. So we'll fade from blue to white. We can see that happening now. And then your particles are exploding over and over. In the game, we just want one explosion. So let's go ahead and check the one shot property. And then finally, let's uncheck the emitting property. Otherwise, the explosion will happen as soon as the tiles loaded in the scene. And we will instead trigger the explosion from code upon the game win scenario. As you can see, there are plenty of properties to affect the particles. Feel free to keep tweaking to get something you like a little better. And there's some amazing tutorials online. I'll list those in the description below. So we'll emit these particles from the center game tile. So we need to give the game tile class the ability to emit these particles. So for now, let's just go ahead and add a reference to the particle node up in the top of the class. And then below, we'll just create a win animation function that we'll call, and that will just simply set the particle's emitting property to true. Now our tile knows how to play this animation, but the tabletop class is where we actually detect that a win scenario has happened. And at this point, it only communicates with the game board, so it wouldn't be appropriate. It'd be too tight coupling to have it additionally talk to the game tiles. So from the tabletop's perspective, we like to just simply have a call to the game board to play the win animation, kind of as we see implemented here. Then we simply just need to implement a function on the game board class. So first get a reference to this center tile and then call its play win animation function, just like this. So that allows tabletop to essentially have the animation play but not have to talk specifically to the tile. Now play the game to a winning round, and you'll notice an issue though. The scene changes before the particle animation finishes. Tabletop makes the call to the win animation, but then immediately makes the call to change the scene. So that's why we see our animation not play through. Ultimately, Tabletop needs some mechanism to enable it to wait until the win animation is complete prior to making the call to change to the next scene. In Godot, a common way to accomplish this is with signals. So in our case, the tabletop will call the game board to play the win animation and then just simply wait for a signal such as win animation completed. In this way, tabletop has no knowledge of the details of how the animation happens, so it keeps it loosely coupled with the game board class. So game board will be calling game tile to play the animation, and it needs to wait for the animation to complete. In this case, we won't use signals. Game tile and game board are pretty closed aggregate systems, so we can just pass a property back in that call as we do here. And then game board will change its behavior and will wait for the lifetime of the particle emission before then emitting the win animation completed signal, which again the tabletop is listening for. So now in tabletop, we just simply yield for the win animation completed signal prior to changing to the next scene. Then with this decoupled signal-based method at the tabletop level, we're free to change the implementation of the win animation, including how long it takes, and this code in tabletop will just continue to work. Now we can play through the game, and when we get to the win condition, we see this animation play. So now we're almost finished with this series. In this game, we added a little visual flourish in the way of a sort of scaling and particle effects. And in the last lesson, we'll be adding music and other audio effects to the game. So that's it for this one. As always, likes and shares are appreciated. And be sure to subscribe and bell so you don't miss future episodes.